Welcome to this presentation entitled Mixing Tank Modeling in ANSYS Fluent, where the mixing of two immiscible fluids will be illustrated. In this presentation, you will find out how to set up and solve a transient mixing tank model in Fluent using multiphase and sliding mesh. The purpose of this exercise is to build a simple, transient mixing tank model to illustrate the Fluent VOF, or volume of fluid multiphase model, coupled with mesh motion. The mixing tank is 1 meter in diameter and 1.5 meters tall. The tank has two impellers. The lower impeller rotates at 60 RPM, the upper impeller rotates at 75 RPM in the opposite direction, and the working fluids are oil and vinegar. The two fluids are immiscible, so the VOF multiphase model has to be used. The mixing tank geometry was built in ANSYS Design Modeler. The mixing tank is a cylinder primitive 1.5 meters high with a radius of 0.5 meters. The two 4-blade impellers, seen here, were built using sketches, extrusions, and patterns. A cylinder primitive was built around each impeller, as you can see here, and then Boolean operations were performed so that the smaller cylinders were subtracted from the large cylinder, and each impeller was subtracted from its surrounding cylinder. The cylindrical volumes were subdivided so that the smaller cylindrical volumes will be assigned rotating cell zone conditions in Fluent, while the larger cylindrical volume with the two cylindrical cutouts will be stationary. Note that the three volumes were not made to form a multibody part. The model was then brought into ANSYS Mesher, where it was meshed using the proximity and curvature size function with a fine relevance center, resulting in approximately 589,000 tetrahedral elements. If you cut the model with a section plane, you can see what the mesh in the different volumes looks like. There are no inlets and outlets. The only name selections are the fluid volumes representing the two rotating volumes, fluid rot upper and fluid rot lower, in the single stationary volume, fluid stat. Contact regions, corresponding to the faces where the rotating cylinders touch the stationary cylinder, were generated automatically when the model was brought into Mesher. You can see those here. That's for the lower rotating volume, and this is for the upper rotating volume. These contacts will be automatically converted into interfaces when the model is brought into the Fluent solver. These interfaces will transfer flow variables such as velocity, pressure, volume fraction, etc. between the stationary and rotating cell zones in Fluent. The model was then brought into the Fluent solver. The mesh was converted to polyhedra. This was done by clicking here on the Setting Up Domain tab and then clicking here on Make Polyhedral. The new mesh has about 147,000 elements, a reduction of close to 75% over tetrahedrals. Moving down the setup tree on the upper left, we start with the General tab. We will use this default pressure-based solver, switch time from steady to transient, click on gravity, and input the gravitational acceleration, which is negative 9.8 meters per second in the z direction. We will then go to the Models tab, double-click on Multiphase, and activate the Volume of Fluid Model, or VOF. We will leave everything else with the default selections. We will just note that the interface modeling type is set to sharp, which is appropriate for when the phases are immiscible, as they are in this case. We will then double-click on the turbulence model, and we will activate K omega, which is appropriate for swirl-dominated flows such as this one. Then we click on the Materials tab. The vinegar and oil material properties were found on the internet and entered here. Next, in setting up physics, we select the phases by clicking here. The order makes no difference unless one of the phases is a compressible gas. Not true in this case, so we made vinegar the primary phase and oil is the secondary phase. Then we click on Cell Zone Conditions, and here you can see the three name selections that we defined in Mesher. Double-click on fluid underscore rot underscore lower, click on Mesh Motion, and set the rotational velocity to 60 RPM. The default rotation axis origin coordinates are OK, as is the rotation axis direction. The impellers will rotate about the positive z axis. Click OK. Now double-click on fluid underscore rot underscore upper, click on Mesh Motion, and set the rotational velocity speed to negative 75 RPM. Then click OK. The Fluid Stat panel need not be opened as it is stationary, and that is the default. Since there is no inlets and outlets, we can skip the Boundary Conditions tab here. Now we can look at mesh interfaces. The two contact regions which were defined automatically in Mesher show up here, and they do not need to be modified. This is what they look like. So now let's close this. Continuing downward to the solution tree. Solution methods, solution controls, and monitors are left with their default settings. We then click on Solution Initialization, click on Standard Initialization, and click Initialize. The entire domain was initialized with 0 velocity and an oil volume fraction of 1. Since vinegar is the denser phase, it would start out in the bottom of the tank, so you want to patch an oil volume fraction of 0 for the bottom half of the tank where the vinegar would be. To do this, you go back to the Setting Up Domain tab, click on Mark Adapt Cells, then click on Region. You want to make a box that is larger than the mixing tank in X and Y and goes halfway up the tank in Z, or up to 0.75 meters. Then click Mark. Now go back to Solution Initialization and click Patch. The region we marked shows up as hexahedron -2 in the regions to patch. Select Phase Oil here in the phase. Click on Volume Fraction, set a value of 0, and hit Patch. Now you are ready to run. Click on Run Calculation, select the time step size of 0.01 seconds, select a number of time steps to 2000, and click Calculate. Finally, we have an animation of the oil volume fraction contours. Here oil is red and vinegar is blue. Initially, the two phases are stratified. You can see that there is not a sharp interface between the phases. That is because the mesh is somewhat coarse, so that it would fit ANSYS Fluent Academic. Now let's hit play and watch the mixing taking place. You can see that the impellers are counter-rotating. The vinegar is moving up and the oil is moving down, and the two phases are being broken up. This concludes our presentation. Thank you so much for watching.